So hello everyone, welcome to the Notary Project maintenance track. So today is the final day of KubeCon EU London this year. So hope everyone have discovered something interesting, learned something new, and made some new connections, and especially having some fun. My name is Yi. I'm a Notary Project maintainer. I'm also Senior Product Manager at Microsoft. So currently, I'm focusing on the cloud-native security and the registries.
And I'm Guillaume Gill, so the technical lead architect at OrangeLogic. And I'm leading the migration of the company to more cloud-native solutions to modernize all the infrastructure and all the things since some years now.
Okay, so it's very great to have Guillaume today as a co-speaker. He will share his company's journey in software supply chain practice and also how Notary Project can help to support this effort. So what is Notary Project? So Notary Project is incubating, self-incubating project, and it is in the cloud-native security domain. So maybe some of you attended the keynote today. There are some talk about the Cyber Attack Resilience Act, this initiative. So Notary Project definitely can provide the support from tooling perspective. Notary Project mainly answer two questions. The first one is, as you see in the screen, it is how I can trust the container images or other artifacts I used. How do I know they are from trusted source? This is about authenticity. Another question is, how can I make sure those artifacts are not modified by malicious users during publishing or distribution? So this is more about the integrity. So Notary Project, our mission is to ensure the authenticity and the integrity of cloud-native artifacts by providing standard-based solutions and tools. So a bit deep dive into the major scenario that Notary Project that supports nowadays. You may see this diagram in the Lightning talk. So this is actually a framework help you to understand how to address the supply chain issues in a systematic way. So starting from the left, it is the acquire stages. So in these stages, you normally acquire, for example, base images from external source. So in this example, Bitnami is one of the major publisher in Docker. So maybe you already know that. So Bitnami, they build, sign, and publish container images and Helm charts in Docker, and they sign with Notary Project signatures. And if you go to Docker and did a search, you can find, as a publisher, they have a guide for consumer that it mentioned that you can use notation to validate the signature to ensure that the images, Helm charts are really coming from Bitnami. So at the acquire stages, you can use Notary Project tools to validate the Notary Project signatures from any external images that you want to acquire for internal use. So after that, you will copy those external images in your internal registries, and as there will be vulnerabilities detected over time, so probably you will use some best practice to scan the images regularly. Then you will probably generate the vulnerability report for later analysis. So for the container images and the vulnerability report, you may also want to sign with your enterprise key, use Notary Project tools, so that it can show it as a proof of use for internal teams. So in the build stages, actually, you build your application images. Normally, you will build on top of the base images that you acquire, or you may have to use some other utility images. So in these stages, so before you use the external images stored in your private registry, you can validate the signature to ensure they are really approved by your company. And in these stages, after you build your own application images, and you probably will also produce some other security-related image metadata, such as BOM for compliance purpose, and also vulnerability reports. So for your application images and those security-related metadata, you may also use Notary Project tooling to sign, so that later on you can validate the signature to ensure they are trust. Now you have your application images, you have supply chain related metadata, you have everything signed, it is ready to for publishing those images. So if you like Bitnami as an image publisher, you can publish to the public repository or any other repository that your customer can access. Then they can validate the signature before use that. Or you are a service team, you release these images for production so that your platform team or service team can deploy those images for your own services. So during deployment, you can validate the Notary Project signatures and the signatures of other security metadata to ensure that the images can be trusted. Okay, so with this approach, basically Notary Project can help you to ensure the authenticity and integrity from end to end. Now I will hand over to Guillaume to talk about his company's practice.
Thank you, Yi. So first of all, to give it more some context, I will introduce a little bit OrangeLogic because probably most of you don't know this company. It's not a tech company or not for you. It's a leading company in the DAM ecosystem. The DAM ecosystem is the way to store assets for a company to make them searchable, to deliver more potential on the assets. And we work for the major company in the world behind the hood. We help them to evolve. And our company provides a SaaS solution to what is a single tenant solution to help them to search all these assets, transcode them, store them, and we speak about petabytes of data around multiple regions in multiple cloud providers. So we have a lot of challenges coming. As you can see, we are multi-cloud. We try to be flexible all over the world. And that ends up with a lot of deployments in the nature, etc. So we try to modernize our infrastructure by being more cloud native and moving away from traditional installation to something based on Kubernetes with, in the meantime, more security. So some numbers, with an example of customers, we have a lot of regions and clients using the application under the hood and a lot of data to process. And we also need for all of that a lot of compliance and certifications. So that's why by making the migration to Kubernetes and to this large ecosystem of tools, what is also a kind of jungle, you probably know it. So that's the best time to leverage a better security on supply chain. To do that, we ask some questions internally. So from where to start? First thing, we need to check and trust the dependencies of our application, obviously. So for that, there is a lot of standards like SBOM and things like that to list your dependencies, to know them. But after that, you have to trust and ensure they are coming from trusted sources. We also need to use asymmetric signature because obviously we all know it to certify something. The best way currently is to use the asymmetric cryptography because you can verify a signature with a public key. You can sign on your side with any mechanism. So that was part of the needs. We also need to prevent the signature being unsafe. Because if anyone can sign, and if the signature is shared over a workstation or whatever, in the end, it defeats the system. So it's not acceptable. And we need also the signature being, being able to work with a tool flexible depending on the technology you use. If you want to use a cloud provider, an HSM device, or whatever else. And to finish, we want having multiple levels of signature. It's a little bit related to our need because of our release workflow, etc. But something we consider is the fact you can sign an artifact going out from your supply chain, but if it's certified at this time, it doesn't mean it's super certified. Maybe it's unstable, maybe it's unsecure to put it in production. So it's coming from you, it's safe, but maybe it's not safe to go in production. So we want to leverage also multiple levels of attestation. So what Notary brings to us? We'll focus on 3 parts about what he presented before. So the build, deploy, and run. On the build part, there is the first rule. Nothing can be trustable if we can be attested safe. And what means safe? Safe doesn't mean only no one inputted something bad on your code or in your dependencies. It can be also something what is unstable. An application unstable is unsafe. So unsafe is large. Second rule, we need to be sure the mechanism is able to be played with an audit to be sure no one can sign transparently from anywhere, and we can't know who has made the signature. So the key must be secured in the right place, and the only way to access the key is to be logged. The third rule is to ensure we can easily verify the key. So as an example, traditionally when you develop software on desktop and things like that, you sign them, usually, and you buy a certificate to an authority, what is providing a high level of trust, in theory. So you embed your certificate in the final artifact, the executable, the DLL, the kernel driver, whatever, and then anyone can verify the signature because the master CA is public. So that's an example of mechanism to verify the source, and it's something what we would like to rely on because we already make some desktop applications. So our first guess was to say, why not use the same mechanism for containers? And the last rule is the fact some other mechanisms are working on transparency logs. So transparency logging is like let's encrypt. Let's encrypt, anyone can create a certificate for it. Until you are owner of the domain, you can create a let's encrypt certificate. It's trusted. That means it's something what attests you are this domain. But if you buy a domain Google instead of Google, nothing proves that you are a good actor. So it's not enough for us to have a global trusted certificate. We prefer trust exactly what we want. And also, the other mechanism of transparency logs is making you mandatory to upload all your build pipeline information or your build pipeline artifact and results publicly on the internet to make them verifiable. And we don't want, as a SaaS company, publishing all of our pipeline stuff on the internet. It makes no sense. So another big interest of Notary, and notation, CLI especially, is the fact it's a tool that is very light in dependencies. We'll see that later. But also something very extensible. That means anyone can create easily an extension for his need. And installing an extension for notation is so simple as making notation plugin install. You provide a URL with a zip or TGZ. Eventually, or recommended you put a SHA to verify the artifact, and then Notation will install the binary in a folder. And then when you use Notation key add, what is the way to register a new key for future signature, you specify this plugin. And what happened under the hood is just the fact that executes that plugin, passing some subcommands, and only 3 subcommands are describe key, generate signature, and get plugin metadata. So that means anyone can build its own plugin for its own need on any language. Can be in Golang, can be in .NET, can be in whatever. So that makes this project really extensible and not close to some specific use case. If you want to use an HSM device on-prem, you can use a community plugin or build your own. If you want to use Azure Key Vault, there is community plugins. If you want to use HashiCorp Vault, there is community plugins. So that makes the tool very flexible. And again, because the dependencies are low, the risk is lower. So next step, once you sign your artifact, you need to ensure it's going where you expect it to be going. So what we decided internally is to put in place a promotion mechanism where for an artifact, so a Docker images basically, you can sign it multiple times with multiple keys and multiple level of trust. So if the artifact, for example, is coming from your build chain, directly from your source code, we sign it in level 1. So it's trusted, it's coming from your pipelines, it's coming from your infrastructure, it's safe. In theory, everything has been verified before, but you are not sure if it's ready for production in terms of stability and maybe in terms of additional CV or whatever. So the idea is to sign it level 0 before going in internal QA. Then once the internal QA is okay and someone, a human or some other asynchronous pipelines are saying, okay, I am happy with this image. It passed some new gates like antivirus scanning, vulnerability scanning, human testing. In that case, someone can trigger a new workflow, what is logged, audited, to sign it level 2. And in that case, the idea is to say, okay, this image is ready for testing on client side. That means any client should safely install it on a UAT environment. And the last step, what can be shortened depending on the use case, is to sign it for production. And with the same mechanism, someone will just click to launch a new workflow. To finish, the key is to verify all that signatures. So that means once the image is going to an environment, the environment must reject an image what is not signed with the expected signature chain for this environment. So you could have a CA specific for production, a CA specific for test, and a specific for QA environment. And everything should be automated to ensure nothing unexpected happens in a wrong environment. So I let you continue on the other part.
Yeah, thanks, Guillaume. So let's talk about why you should choose Notary Project. So first, secure. So we are security tools, right? So ourselves should be secure. So Notary Project, we regularly apply the security best practice by going through the security audit by third parties. As you can see in the table that our very first major release, we have done 2 security audits in 2022, 2023, and last year, 2024, 2025, we also did another security audit on 2 important features. One is the timestamping, another is the revocation checking. So our quality is the best in class. And we plan to do another security audit probably later this year, early next year. Another reason that Guillaume also touched a bit is Notary Project. We are building our solutions tools based on standards. And we also have the extendability by providing the plugin framework. And also we focus on enterprise scenarios. So as you can see on the bottom, we have Notary Project specifications. They are building on top of standards. The OCI Standard Open Container Initiative, which allows you to manage artifacts across registries, across multi-cloud platform. We also support IETF standard signature format. One is the JSON Web Signature, which is popular. Another is CoC signature. It is binary encoded, which is very concise and efficiently, especially useful for edge or IoT cases, for example, for the low power devices. From the plugin side, we have a plugin from major cloud provider, such as Azure Key Vault, AWS Signer, and also Alibaba Cloud. And we also have some other plugins by some vendors. And we have a HashiCorp Vault plugin. Currently, it is in alpha state. So welcome anyone to contribute into this plugin. And we are also working on a new plugin. And with this new plugin, we enable the ephemeral key support, or we call it the short-lived certificate, and also zero-touch certificate management. And we also integrate with the whole ecosystem. So currently we have the CI/CD pipeline, Azure DevOps, Flux CD, and also GitHub Actions integrated with Notation. And we plan to integrate with Argo CD and GitLabs. So also if someone is interested, feel free to reach out and help to contribute. Another reason why you should consider Notary Project, you can see in the screen, it is the tools and the libraries that are built by Notary Project. So as a security tools, we minimize our dependencies. So the whole problem of the software supply chain is due to the fast growing of the open source projects, right? You can just acquire and use. But as a security tool, we should minimize our dependencies. Otherwise, we will have our own secure supply chain issues. So as you can see, the three major repositories, we have very few dependencies, especially for the first one, timestamping client. So if you work in the security area or interested in this area, you want to build some timestamping related client for interact with timestamping server for your short-lived certificate or timestamping related scenarios, you will not find any good libraries in the industry. So timestamping client is another major contribution that the Notary Project provides to the whole ecosystem, and we have zero dependencies. And we have currently we have popular adopters from cloud providers and registries. So actually, any registry supports OCI standard is Notary Project can be used for. And also admission control engines such as Keyboardo also support Notary Project signatures. Something about roadmap. So we basically complete all the core capabilities for sign and verify OCI artifacts. So now we are working on extending the sign capabilities to the other artifacts that are not stored and distributed as OCI artifacts. So such artifacts could be, for example, spawn for your binaries, or AI model files, or WebAssembly model files. And as OCI getting popular, so we will change the default behavior to by default support OCI 1.1 reference API, which is more elegant way to manage your signatures. And we will also make, so currently working on making our experimental feature sign and verify OCI image layout, which is the kind of images you can put on your file system. You don't have to store in the OCI registry first. you can put it on your local file system, you sign it, then you put it to the registry, which is more secure. And in the future, we plan to support attestations. Probably we will work with the in-total community to support in-total attestations. And we will also working on the transparent lock. And we will also build it based on the IETF standard. We still have 5 minutes, so I will give a short demo on our new feature, which is about assigning blob files on your file system. Okay, so taking a spawn file as example, so you build a spawn file on your file system in your trusted domain. And before you publishing it, you want to sign it to ensure the integrity and the authenticity. So I'm using the notation, the alpha version. I already have my key provisioned. Currently, I'm using a test key. Then after that, I can use the new command set, notation blob sign. I choose the format cozy, a binary format for the signature, and the media type is SPDX. Yeah, so after that, I signed the spawn file. I have everything on my file system. It is not leaving my trust domain yet. So now I publish in anywhere using any file transfer or method to publish the spawn file and the signature together, so that later on any consumer want to consume the spawn, they can validate the signature first. Okay, so I have everything downloaded on my file system as a consumer. And this is to check I have the root C certificate configured. That is the trust angle. Then for Notary Project, we have the trust policy, which you can fine and tune your policy according to your requirements. So I initialize this trust policy with the trust store, as just shown, and the trust identity, which is the subject field of the signing certificate provided by the publisher. Then I show the trust policy that configured. It is as expected. Then I can start to verify the signature. Yeah, it's easy. I just specify the policy name, the spawn file, and the signature. Okay? So after signature verification successfully, I can start to analyze the spawn file. Oops. Yeah, so with that, I think we complete all the content. So any questions? Yeah, there are 2 QR codes here. One is Notary Project website. Feel free to explore and bookmark. And another is the Slack channel under the CNCF community. So you can find the Notary Project Slack channel. Ask any issues, questions there. So if you have questions, you can stand in front of this microphone to ask. Look. Okay, thank you.